Wow, that's loud. You guys have to tell me if I need to, because I have a pretty big voice anyway. So, anyway, we're going to get started here. Start with, buckle up. I talk fast. We have a lot of things to cover. We're going to go back between process, to theory, to technology. We're going to move right along, and at the very end, you're going to see the most complex demo you've ever seen at any event. So what does this mean? This is kind of an odd title, and if I had to do it over again, I might change it because it didn't come up in the search very well. So let's break it down. So Peerless Data Analytics Engine, that's obviously the Qlik Data Analytics Engine. We're going to combine that with sensible Qlik architecture. And this is really the core of what we're going to talk about today, is how this architecture with Sense really opens up the possibilities of what we can do. And we've seen that already. And in the end, I'm going to convince you that that's going to lead us to limitless in-memory analytics. So I've said that to a few people since I got here, and most of them just shake their head and walk away. So just trust me, we'll get there. It'll make sense. But let's move into this. Who are we? And more importantly, why should you care? So, and that's always important when you're talking to people. So I want to start out with my partner, Rolf Boettcher. Most people know Rolf in this world. He's a genius extraordinaire. He's trained oodles of people. He works with TIQ, a partner of ours in Germany. We work back and forth. And I don't know what to say. He's got a genius mind. So you want to add anything to that? Okay, all right. My name is Travis Rogers. I'm Senior Director of Delivery at Bardess. Bardess, we transform data into impact, and we do it every day for the most demanding clients around. So I know that's not really enough, but I gave you a title and the name of our company. And I put this up there because my son, who's a little older than that now, informed me that my other picture looked like a wanted poster. So I thought, well, I'll just go with it. So why should you listen to me? You never heard of me, whatever, I'm always in the background. So I'll give you a couple things that I've done. Has anybody in here ever listened to music? Anybody? Raise your hand. All right. Has anybody in here listened to more than 3 songs in the last week? Any kind of song, doesn't matter. Everybody? Oh, good. All right, good. You're welcome. I have architected and helped write 2 of the world's most sophisticated royalties processing systems that pay the writers of those songs. And I've had the opportunity to do it in 2 different ways. One, what I'll call the traditional relational data model, and the other one I'll call, crazy, bleeding edge, microservice, polyglot persistence, whatever terminology you want to use, we tried to throw it in there. And so I've had a lot of experience with a lot of data and a lot of complex formulas in every country, dealing with money from every country on the planet. I had a few people on my team that came from the financial world. They were quant people. And I got them working about a month into that. It's like never seen anything so complex in my entire life, so just to give you a sense. So why did I do this presentation? Well, one, it's kind of fun, but the other one is I really do it because architecture matters, right? This is kind of a thing for me, is what does the architecture do? When I talk to a vendor, when I talk to a client, it's like, let's talk about the architecture, let's talk about the plans. So architecture really matters. And so I thought we'd start out with the greatest architectural feat of all time, which is the Pyramid of Giza. 2 million massive stones in that thing, 88 million cubic feet of material, 11 billion pounds, 200 million man hours to build. And to be honest with you, nobody really knows how it was built. 4,500 years still standing. And for 3,800 years, it was the tallest man-made structure on the planet. And I tell you, not the greatest architectural feat of all time. In fact, I'll say it's one of the worst architectural feats of all time. So bear with me. There's no fruit in the back, so we're okay. So I'm going to give a little context, because it's not just about architecture. There's always a context for opinion, right? Now, I assume, just like music, everybody in the room has heard of Agile processes, right? So Agile is important, and it's going to inform our opinion about the architecture, but really we want to talk about what Agile actually meant, not what it is today. So Agile, we see this in businesses where we come in, and what we actually see is Wagile. Wagile is Waterfall sort of wrapped in Agile, right? So we're doing all the processes, but we're still following the same Waterfall planning and concepts that we did before. And some other ones that we get are Scragile. So Scragile is Scrum only Agile, right? So every day, we do Agile, we are Agile. We follow, what do? Well, we go to a stand-up meeting every day, right? That's it, that's what people know about. That's not Agile, that's Scragile. Whoops, sorry. Then there's Stractile, which is sort of the other end of the spectrum. That's structured Agile. I'm going to say that again because those two words actually don't belong side by side. Structured Agile, okay? That's the business that says, we're going to follow every single cadence to the letter. You're standing up, you're passing the ball around, 15 minutes, we're out of here, everything, doesn't matter. But are they really any better off? And is structured Agile the concept that you want to achieve, right? And often we see businesses with processes that are still fragile. So as we're going through this process, we want to talk about small a Agile. We want to talk about the Agile that you get when you look it up in Webster's dictionary. Agile meaning marked by ready ability to move with quick and easy grace. Or if you like dictionary.com, my favorites, they're right quick and handy. An ability to think quickly, mentally acute, or aware. This is the Agile that needs to inform our architecture and that our architecture needs to support. Now, most people, when they look at this definition, because they've been doing big A Agile for a while, this is the first thing this is what they notice, quick. You know, fail fast, hurry up, quick and dirty, all those terms, there's a bunch of them, right? But they see the quick part. We actually want to think about these parts, right? We want to do things with easy grace. We want to think, we want to put some mental acuity into the equation, right? That's actually what the original Agile was intended to do. And we put this together and said, look, the ability to think acutely and act with rapid, easy grace is our goal. And that's what architecture should mean to us, right? When we do an architecture, when we talk about architecture, those are the things that are going to inform it. So, greatest architectural feat of all time, craftsmanship and ingenuity. I mean, it's there. It's phenomenal. If you read about it, the way it's lined up with the stars and everything else, it's crazy. The magnitude, we talked about, it's massive, undeniable, and longevity and fortitude. It's been around for a long time. So that would seem to still argue that this may be the greatest architectural feat of all time. The problem here is that it's monolithic. It does one thing, and only one thing, and to be honest with you, it didn't do it very well because a few years later somebody got in that thing and took all the good stuff out, right? So let's talk about what it means and why monolithic is not such a great thing, right? So when the ground shifts, and by the way, you may not know this interesting fact. This is the King's Chamber right here. It has these interesting things right here. The ground actually did shift when this thing was nearly 3/4 of the way done. Let me put that in perspective. After 150 million man-hours, something went wrong. And it's a something that you can't do anything about it, right? And we know that. I can tell you why later, why we know that. It's an interesting little tidbit. But we actually want to be able to start over and repurpose what we've done. There's no starting over in this situation. So the next thing is when requirements change, right? So the Pharaoh comes to you, says, hey, look, we need architects there. I'm going to be massive, very impressive. I only need 3 things. I need a chamber for me, I need a chamber for the queen, and I need a chamber for my goods, right? That's it, my boat and all the stuff, right? That's it. So we're halfway done, and the king says, the Pharaoh says, hey, look, the queen came by, and she kind of wants, a rumpus room, right? If she felt like we needed to park the chariot on the inside, right? Now what are you going to do? You built this whole monolithic thing. How are you going to change, right? So we need to be able to adapt or die, and the architecture needs to support that. The last thing is when the work is done, it has to be useful. No matter what the work is, when it's done, it has to be useful. And I will say that this little 3-bedroom house, built with little boring technologies like plywood and dimensional lumber and using platform framing, is way more useful than the Pyramid of Giza. So this brings us to Bardess's first law of software architecture. You can probably kind of guess what it is. Architecture either empowers agility or obstructs it. That's it. That's the law. It's either achieving one or not. So let's do the side-by-side. Craftsmanship and ingenuity, who cares? We don't even know how that thing was built. So yeah, it was a great craftsmanship. It didn't inform anything we did afterwards. It didn't help us. It didn't achieve anything. So it's very cool. But what purpose does it serve today? Wow, that's big. That's it. That's what it does today. Magnitude. It's huge. But let me tell you something. If today you decided to spend 200 million man-hours building a 3-bedroom houses, you could house over 500,000 people with that. That held the king, the queen, and some goods for a while, right? Longevity and fortitude, it's definitely lasted a long time. How can I beat that? My house isn't gonna last 4,800 years, that's it, right? But the truth is, if every 30 years I built a new 3-bedroom house, until I consumed 200 million man-hours, I could live in that house for 3.2 million years. That's longevity. So, let's get to this. Why sense? Now this is one of my favorite questions to ask people that I interview. So I guess if I ever interview you, have a leg up. And maybe we'll put the thing out there and I'll have to change my questions. So, but the question is, I ask people is why sense? Why did Qlik go through all the processes of throwing away what they did and re-architecting the whole deal? And the answer is, I don't really know. I wasn't there. I can only hope that these are the things that they went with. But really, why sense is, first of all, agility matters. And the second thing is that architecture matters. And the third thing is the rule. It either empowers agility or obstructs it. So why sense? It's fundamentally more resilient, flexible, and empowering architecture. And I'm not talking about just sense versus view. I'm talking about other tools and technologies out there. So let's talk about agility, what it has. We're going to spin through these pretty quick. So one piece of software I can have it on my desktop. I can have a nice little server version. I can have a couple nodes. I can have a ton of nodes in high availability, and I can do all that in cloud. That's configuration agility, right? Now we have license agility. You can do perpetual, subscription, professional analysis users. We can pay by CPU cores, and now there's going to be probably a new model for the Clickpoor. Whoops, keep doing that. Software agility, microservice, API first, cloud hybrid ready. We've seen the benefits of that just in the presentations earlier this week, right? Native mobile, UI extensions, mashups, ODAG, and another little thing that we're going to spend a lot of time talking about, which is server-side extensions, okay? Server-side extensions is the ability to call from a Qlik application on the server, that's sitting on the server, to any other functionality you want, right? So some examples, and I know we've all seen R and Python, those are the things that are out there. I can call out to any database, I can use Cloudera, I can write my own node apps to do whatever I want them to do, Java, you name it, we can do it. Because now I've been empowered by this little window to be able to connect Qlik's microservice architecture to something I want to do. So that's what server-side extensions is, and this is kind of why it fits well in this architecture. Now one thing we kind of didn't mention here, which is core to this conversation, is this is API driven, this is API driven. I have server-side extensions. I can actually have Qlik sense talking to ClickSense or Clickpoor. Okay, that makes sense? All right, let's talk a little bit about Clickpoor. I'm not going to go too much into this. I think everybody's seen the, been to some sessions or whatever, but it's a development paradigm built on top of the Qlik associative engine, right? It's sort of a developer first. Here's our associative engine, go do some crazy stuff with it, right? And they gave you some opinions about what you might want to do. It's built on Linux, Docker, Kubernetes. They've open sourced the Picasso.js to interact with it, right? Now, why are these important? These are important because these are things that let you do, automation, spinning things up and things down, elasticity, those sorts of things. So additional flexibility, right? And of course, everybody wants to know, and I don't know the answer, is the memory usage faster on Linux than it is on Windows? I have no idea. Maybe someday we'll try to answer that question. Now, I said earlier that I'm going to get to limited in-memory analytics. If I can connect ClickSense to Clickpoor using ServerSide Extensions, and I can have as many Clickpoors as I want, and I can put those on as many machines as I am willing to pay for, I can be limitless, right? So, we're going to talk for real quick some things that we've actually done with server-side extensions, and then a little bit after that we're going to go into some conceptual things that we've done with Clickpoor in this combination. So, this is actually, we were part of this. We weren't the original conceivers. This is sort of build your own app. So, the concept is there's a in-memory analytics engine that's sort of monitoring your data warehouse, seeing usage and metadata and stuff like that. You connect to that with a web page, and I'll just let it play. I think I have a player. You connect to it with a web page, you pick your tables and your columns and stuff like that, and you hit go, and it generates a Qlik app, right? This is actually, I think, a competing, so please, again, lock the door. There's a competing session showing this in more detail elsewhere, but we were involved in helping out with that. So that's called Cloud Data Explorer, is what's there. And I think you can see it downstairs too. So that's one thing, gives that capability. Here's one where we did something where we used server-side extensions and ODAG in a workflow. Okay, now I have a nice picture, but it's not as simple as that. I'll try to explain it as best as I can, all right? So right here, we've built some template applications, some data load scripts that are ready to go. The first line of that script is a call out to a server-side extension, okay? So, and if I loaded that without the call out, it would load a lot of data into a really slow application, right? It would load successfully, but the refresh and stuff like that would be not that great, right? Now I have another problem here is I have a business user that wants to bring their data to the party. Excel spreadsheet, I want to bring some data in there. And I have a second complication that says, hey business user, you're not actually allowed to just throw whatever you want into a BI application. We have to run it through some security stuff, right? So there's a separate web page where the data is loaded into the database, processes are ran on it to make sure it's all good, converting some data and stuff like that, all existing stuff that the bank that we work for already did, right? And then when it's done, it creates a table. That table never existed. We had no idea what the name of it was going to be, right, before that happened. So we could not build it into the script, right? So what happens is once that's done, it notifies this server-side extension piece of code, which then says, aha, thanks for giving me the name of the table, and then triggers the load. It lets the load continue. And now and so two things have happened here. The user has brought their data, it's been scrubbed through a process to make sure that it's secure and has the right data in it, and we've actually created an app that's smaller than it would have been because we've used that data that they brought as a filter, right? That's all through server-side extensions, some combinations of ODAG. Here's a new one we're working on. This is pretty interesting. So this is server-side, I've given it 5 names, so I got to read it. Server-side extension direct access imprinting, right? So this is, I don't have time to reload the data model so that the imprinting has the latest data for one reason or another. So what I really need to do is just when I run imprinting, I need to go out to the database and get the latest data to show up in my report, okay? Does that make any sense? So the use case here, one of the use cases, there are about 30 of them, but the easiest one to understand is the person goes in and they want to change their name or something like that, and then they want to print out their ID card with the new information, right? And they want that to happen like that. Change their name, hit the button, and go. You know, less than 2 seconds. So the user goes to a web page, they enter their data, it goes to the internal data store. We don't have time to refresh all users' information for imprinting, so they hit the big blue button saying send me my PDF. It executes imprinting. Imprinting uses server-side extensions to call out to get the data, creates a report, and sends it back to the person in PDF. I will tell you, we're still testing that one. It's going well. We'll let you know. So server-side extension text-to-viz. So we've all, I think probably everybody's seen, I can type in, and I'll show this while I'm talking. You can go to a bar and type in information, it brings back graphs and stuff like that. The implementations we had seen prior to us building this, and I think some others have done it since then, was that it was all happening in the browser. All that logic was happening in the browser, which makes it really hard to run on a phone. It also makes it hard to add really super complex, logic to it, natural language processing and stuff like that. It also makes it hard to add configuration for the specific app and things like that. So we re-engineered it so that it uses server-side extensions. So when you're typing into that bar, it's actually passing what you've typed through server-side extensions to some scripts on the other side, Python and some control files and some other stuff, and then it's passing back the information that you see. And if you've typed in enough information so that it can create a graph, it will send you graphs. And you can tell all the graphs you want, stuff like that. This is a scalable production type solution to what people wanted last year. Right? When people saw this, can we do this? No, it's not ready for production. Using server-side extensions. And just imagine what you can scale this across multiple nodes, whatever you need to do. And the great news is I can do this on a phone. And oh look, oh I missed it. So you can actually talk into your phone because your phone capability and get that information that way. Right? No problems with the phone. All right, so we've been through some examples of things that we've done. Now we're going to do 2 steps. We're going to talk about some very basic ideas, and then we're going to get a little crazy, right? So I just want to tell you this is like new, never before seen. It's not production ready. Qlik does not sanction me saying this, all that stuff, all right? So I just want to be clear, absolutely 100% clear. I'm going to show you some ideas. I'm going to show you that we can do it. But it's not production ready, and Qlik wants you to know not to come ask them about it. Okay, so got that out of the road. So back to agility. So solution agility. These are the concepts we talked about. So this is a mental exercise that we did. What would be possible if a typical Qlik Sense application could utilize many Qix instances, right? And then we said, what about if you could do it across a bunch of nodes? What kind of problems that we have every day could we solve with that in mind, right? So let's start with the simple stuff. I have this application, I need some detail, and when I put the detail in, it starts getting sluggish, right? It loads up, takes up a bunch of memory and stuff like that. Now there's a bunch of ways to solve that problem, right? Optimization, so forth and so on. Then I add some more data and I gotta re-optimize, and I add some more data, I gotta re-optimize, that's the process, right? So let's talk about something simple. I have some aggregated data or some base data over here, and I have my detail over here on another machine, taking up memory somewhere else, that is providing the answers to the questions. And using server-side extensions, I'm sending queries out, getting the information back, presenting it in my original app over here, right? User, key thing here, user doesn't see any difference. That's the theory. It's not quite that easy, but it should be. So let's go to the next one. Same situation, right? We see this, if you've done this, you see it all the time, right? I have years and years worth of data. Once in a while, I need the stuff 10 years ago, and if I don't put it in there, somebody's gonna be pissed the once a year that they need it. So I'm gonna chunk it into the app, and then it's gonna slow everybody else down, right? How do you solve that problem? This is not a by the way, these are technical standards. I'm not coming up with these, obviously. You could probably all know these. I'm just presenting them on a page. So there's no genius here at all. So we're going to shard them, right? We're going to put some years in other engines. And we're going to have a main engine over here. Maybe it has the most current data, maybe it has some aggregates, whatever. And it's going to call out to those and get the data that it needs based on the shard, right? Now there's a bunch of problems here. But conceptually, this is a solution to problems we see every day, right? That basically there's no solution to, other than continually tweaking your data model and stuff like that, which is not what we want to do. So the next one is what I call sharded formulas. So the last one is sharded data, right? So we've all been in a circumstance where I built this great application, especially, by the way, with Sense's self-service, right? This is the thing. I built this great app, it's this great data model, and then somebody comes along and they do exactly what I asked them to do, and went in and started building things, and they created some formulas that is exactly what they need, which is exactly what I wanted them to do, that slows everything down, right? Now what do I gotta do? I gotta get somebody back involved, they gotta optimize it, maybe they gotta create a separate app, maybe we need to do some ODay, maybe we need to do it in the load script. Now all of a sudden I went from self-service to work I thought I was gonna get away from, right? So what if we could just offload some of the work across a bunch of machines for the exact same data set? I create one data model, I put it across a bunch of nodes, I have a little system here that says who's busy, who's not, and then I go to this guy to get the answer to the thing, and I'm not killing my users on this side. Okay? All right, the next one is non-disruptive reload, right? Okay, everybody, again, knows this problem. I need to load data, I need the most recent data, I want it in my data model, all those things. And doing reloads every 5 seconds is not great, even if you can make it happen, and there's all kinds of work around this. So I'm going to walk you through this. So here's this guy here. There's a visual to it, but it's just for my benefit because I thought it was cool. This guy here is actively serving up the data to your app over here, like we've seen in other circumstances. That guy up there is getting the data loaded into it, and then eventually things swap out, and this guy goes into like an archive. So we'll animate it, just because I spent a lot of time getting it to work. So that's the concept, right? Again, I'm getting data loading in. This is a great streaming example, but it's really micro streaming for if you really care. So again, common thing that we can solve. So right now, let's think a little bit deeper. Now that we've seen all these things we might do, and we're going to demo a couple of them, right? Now let's talk about what's next because of all this agility and this architecture we're talking about. So I have this super awesome Qlik multi-node environment over here serving thousands of people in self-service. It's awesome. I have this super powerful data processing, data accumulation system over here. That's great. And now I have to do that. Right? And it's not just speed, we can tweak it, we can run fast, we can do all that, but somebody has to build these data models. Somebody has to ask the question, I would really like some data that told me X in order for us to go figure out what we need to build, right? So there's a big pipeline process here that we have to deal with. So how do we start solving that problem with all this agility, right? So this is a little what if exercise. What if there was something in the middle here which got metadata and usage information from both of these places, right? And what if in that thing in the middle there was this great analytics engine, API driven, that allowed me to use that data in unique and interesting ways, right? Oh yeah, that's kind of what Clickpoor Data Explorer started doing. It's not all the way there yet, but that's kind of the concept it's built on. What if within that I could call out to other things that let me do predictive analytics on that information? Now what? What if I could scale up and just start creating data models at will based upon what I've learned through this process? And then I could push them to my super awesome multi-node Qlik instance for people to use and validate. Right? To say, yeah, that's a data model I'm interested in. right? Turns out I wanted that data model, I had no idea. So I call this user-targeted, machine-rationalized data assets. I haven't figured out a better word yet, so, or a combination of words. We've tried to put some stuff, so that's what it is. So we'll change it another day. So that's the conceptual stuff.